This video covers chapter 25, which is about two categorical variable tests. And for that, we're going to use the chi-squared test. So the chi-squared test, chi being like the Greek letter chi, which you can't see because it's blue, is used to determine if there's a relationship between two variables. So what are we going to talk about today? Well, first, we're going to talk about two-way tables, the problem of multiple comparisons, expected counts in two-way tables. This is a little calculation that we're going to need to know in order to calculate the chi-squared test statistic. We're going to take a look at the distribution of chi-squared data, cell counts required for the chi-squared test, uses of the chi-squared test for independence and homogeneity, and the chi-squared test for goodness of fit. So a first place to start, before we even can compare any two variables, is going to be with two-way tables. And you have seen these before, specifically when we were working with proportions. So the two sample Z procedures we did in chapter 18 allowed us to compare the proportions of successes in two groups, or either two populations or two treatment groups in an experiment, right? When there are more than two outcomes, or when we want to compare more than two groups, we need a new statistical test. And for that, we need a chi-squared test. And this test addresses a general question. Is there a relationship between two categorical variables? Two-way tables of counts can be used to describe a relationship between any two categorical variables. So let's take a look at some two-way tables. So, for example, a sample survey asks a random sample of American adults, do you consider yourselves a have or have not? And table 25.1 is a two-way table of all 1,867 people in the sample, classified by their political ideology, of which there's definitely more than two options, right? And whether they consider themselves to be a have not, neither, or refuse to answer. So whether one considers oneself a have not, or refuse to answer is a categorical variable, and so is political ideology. So we put one categorical variable, the have not, on one side of our table, and the political ideology on the other. So what we want to do is we're going to want to calculate the conditional distribution of proportions of have or have not for each ideology, make an appropriate graph for comparing the conditional distributions in part A, and see, are the distributions of have and have not under the three ideologies similar or different? And we're going to give appropriate evidence from parts A's and B's to support our answers. So for that, we're going to take out of the total and start to calculate our proportions. So for example, for conservatives, have would be 460 out of 725, and we convert that to a decimal. Have not would be 184 out of 725, because there were 725 conservatives. Neither would be 45 out of 725, and 36 would be the refuse to answer out of 725. So let me show you all those calculations on the next slide, right? We're just converting everything to a percentage. So, like I said, haves was 460 out of 725, which gave us 63.4%. Have not would be 184 out of 725, which is 25.4%. Neither was 45 out of 725, which is 6.2%. And refused to answer was 36 out of 725, which was 5%. Now, all of these percentages together should add up to 100%. Otherwise, I might have made like a math mistake or a rounding error. So we're going to do the same thing for moderates and liberals. Let me show you those calculations. Just converting it to a percentage. Notice our denominator changed for moderates because there were 629 moderates, and it changed for 513 to 513 for liberals. Notice because these are broken up into groups, I'm not really examining the totals column right now, like we might have done when we were calculating probabilities. So for part B, I want to go ahead and make an appropriate graph of this information. So let's look at the graph. So here I have conservatives, moderates, and liberals. And based on these distributions, is there enough evidence to support that they're really different? That the distribution of their considering themselves have or have-nots is different by political ideology? And just from looking at this, I'd say no, right? They all kind of follow a very kind of similar left-skewed moment at this time, right? So